Good afternoon, and well, good morning, good afternoon, good evening. I'm not sure what time you are watching this video. Today, we're going to continue our discussion and give you some information about the standard deviation, or holistically, we're going to talk about measures of spread, and then I'll do a separate video on measures of position. So it's not much. And I want to assure you that we are doing these calculations with calculators, SPSS. I'm going to show you how to use SPSS in a video. Today, I'm just going to use an online calculator, just in case you haven't purchased it at this point. So let me go ahead and switch screens now. I am going to stop sharing my personal screen, and I'm going to share my document camera. And I'm going to get rid of, well, I guess I'll leave my face up here so you can kind of see me talking through this. So today I want to start with this question, which was the extra credit. It was from the extra credit reading. And basically, one can pull from that, should these students earn the same grade? So when you looked at the extra credit, I think it organized the data by class. It had class 1, class 2, class 3. But since most of you are educators, I'm going to say, let's suppose we have 3 students, Ann, Bryce, and Charles, and these are their grades. Ann has 67, 366s and 65, 82, 82, 82, 42, 42 for Bryce. And then Charles has an 82, 78, 70, 58, and 42. Well, I'm not going to waste much time, but I will tell you that if you were to, actually, let me see if I can focus this a minute because it looks a little blurry. Cut the light on and try to focus. Just a second. Give it 1 second to focus, Claire. I will tell you, again, from the reading, what's interesting about this data is that if you took the mean of the grades for each one of these students that is found X bar, guess what you would get? A 66. So if I added up all 1, 2, 3, 4, 5 numbers and then divided by 5, I will get a 66, which means all of these students should get or earn a D. Now, I will tell you, it is not good to make any kind of statistical decision based on one statistic. That's not a good thing. So one of the things we want to do is use a measure of spread. So let's talk about the measures of spread. There are 3 of them. Basic 3, there are more than 3, but the basic 3 would be the range, the variance, and the standard deviation. Of course, if I'm writing too quickly, take a minute and pause the video and so that you can write and catch up with me. Watch it a couple of times. I try not to make them any more than 30 minutes so you can at least watch it twice. So range, variance, standard deviation. Let's talk about the range first. I'm not going to talk about the variance because it's not something we actually use, but I will tell you that the standard deviation is by definition the square root of the variance. So you cannot find the standard deviation without finding the variance. But we do not like to use the variance as a statistic for interpretation. We would prefer to use either the range or the standard deviation. Let's talk about the range and then we'll talk about the standard deviation. I'm going to show you how to do them by hand. And then I'm going to show you how to use a calculator so that you can get your homework done very, very fast. All right, so Roman numeral 2, the range. The range can be found by taking the smallest number and subtracting it from the largest number. So if we were to look at Ann's grades, go back and look at Ann's grades, the range for Ann would be 67 minus 65, which means her range is 2. And then if you look at Bryce's grade, I didn't mean to put an E on Ann, forget that. Bryce's grades, I'm just going to put R sub B. This would be 82 minus 42, which means Bryce's range is 40. So let's just stop here for a second and talk about this. So when we think about spread, we're talking about spread from the mean, spread from the average. So what this says is Ann made a 66, but her numbers were very close to that 66. There was not a lot of spread, okay? There was a lot of consistency. So this means that Ann made a 66 consistently, okay? This is about consistency. Ann made a 66 consistently. So if Ann is supposed to get a grade, we're going to give Ann a D because 66 is a D at most schools that I've attended. I'm not sure what it is at Hampton, but you don't want to know what a 66 is because you're graduate students and you can't make a 66. All right, so, but we're going to say right now a 66 is a D. Now, what are we learning about Bryce? Well, again, we subtract his lowest grade from his highest grade, the range is 40. So that tells me it's not consistent. That is, Bryce has some high grades, Bryce has some low grades, but they really do differ from this 66. Okay, the grades as a whole differ from the 66, which means he probably should not get a D. Also, if you look at Charles, 82 minus 42, Charles also has a range of 40, which means that Charles should not get a D. So right now, all we know is that Ann should get a D, but because Bryce and Charles had a range of 40, we're going to have to do something else because they have the same number. So that's not enough information to distinguish who has more variability or who has more spread in their grades. Now, I want to tell you that the range is the least informative measure of spread. It is the least informative measure of spread. All it tells you is that your numbers are close together or your numbers are far apart. Now, let's go to the big board, the standard deviation. And we're going to calculate the standard deviation for Bryce's grades. And I'm going to show you how to calculate the standard deviation for Charles's grades using an online calculator. So I'm going to do Bryce's grades by hand and then Charles' grades by an online calculator. Now, if you look at that article, you saw, okay, first of all, let me write standard deviation. I'm getting so excited. I forgot I need to talk a little bit about what this is. The standard deviation represents the average difference from the mean, that is X bar or mu. Remember, mu is the mean of the population. Now, there's a formula for the standard deviation, and you saw that scary looking formula in that article that I asked you to read for extra credit. I'm going to give you two formulas, one for the population and then one for the sample, but we're going to focus on using the one for the sample. As a matter of fact, let me start with that. We'll write S for standard deviation, and we're going to say that is equal to the square root of the sum, you remember this funny looking symbol sigma, of the squared differences about the mean, all divided by the sample size minus 1. Now, I know y'all gonna hold up, that's too fast. Okay, but again, you can pause it. Standard deviation is equal to the square root of the sum. Remember, sigma means to add. This is not a variable. It means add up a bunch of numbers. Matter of fact, add up a bunch of squared numbers. That's all it says. The numerator says add up all of these squared numbers and then divide by n, the number of grades in this case, or what we like to call the sample size, minus 1. The population is very similar. We have another funny looking Greek symbol called sigma. This is also called sigma. This is uppercase sigma. That's lowercase sigma. This one is a variable. This one is the operator. This sigma is a parameter. It represents the population standard deviation. Calculated almost in the same way, the square root of the sum of the squared differences about mu, the population mean, all divided by the entire sample size. Big N represents the entire sample size. Again, you don't have to be afraid, but it is important to know whether you're calculating the population standard deviation or the sample standard deviation. Most of the time, this is what you're going to be doing because you just have a sample of data. So that's what I'm going to do. I'm going to show you how to use this formula for Bryce, and then we're going to show you how to use the calculator for Charles and put it all together to answer the question, because that's where the learning will occur. So this is going to be done in 3 steps. First, we're going to calculate the numerator, then the denominator, and then we're going to take the square root. Top number, bottom number, square root is 3 steps. It looks like a lot, but it's 3 steps. All right, so I'm gonna go to another piece of paper and I'm gonna say step 1, the top number or the numerator. Now to do that, we're gonna make a little table. I'm gonna put all my data in the first column, and then I'm going to find my differences or my deviations in the second column. And then in the third column, I'm going to find my squared differences. And I'm going to talk to you in a second about why I'm squaring these numbers. This part of the process is the tedious part of the process. Everything else is pretty straightforward. So we're going to write 82, 82, 82, 42, and 42. Now, what does this tell me? Subtract each number from the mean. And remember, the mean is 66. So this is 82 minus 66. Do that 3 times. And then 42 minus 66. And so I'm going to let you get your calculator. Take a minute and find all of these differences. I'm going to get my calculator. Got my little calculator here on the side so we can find these differences. All right, let's see, calculator. And I'll even show you what I'm doing in the screen here. All right, so I'm going to say 82 take away 66. That is 16. And then I'm going to say, be careful with this one. 42 minus 66. That's, you can't see that, but that's negative 24. So be sure to look at the calculator. It's going to tell you, let's see if I can show it to you. Yeah, it's going to say negative 24. And it's not going to matter because I'm going to square each of these numbers. That is, I'm going to multiply each of these numbers times itself. In other words, I'm going to say 16 times 16 is 256. And I have that 3 times. And then 24 times 24 is 576. Now let me stop for a minute and tell you why I'm squaring these numbers. If you were to add these numbers, just a little bit of algebra, and I'm not trying to scare you, but I'm just going to explain it for a second. We're looking for the average difference from the mean, from 66. These numbers are 16 points above the average grade. This score, 42 and 42, are 24 points below, that's why it's negative, the average grade of 66. The question is, how far are these grades from this 66 on average? And now you know the way to find an average is to actually add up all of these deviations, these differences from the mean, and then divide by 5. But if you were to do that, add these 5 numbers together, then you would get 0, which is not helpful because 0 divided by 5 is 0. So what we do is we square all of the numbers to make them positive. So we don't have to deal with positive and negative numbers and worry about all of that. So this last column, the sum of the square deviations or sum of the square differences would be, let me add it up, 256 plus 256 plus 256 plus 576 plus 576, and that is 1920. So our numerator class is 1920, 1,920. Again, if you want to pause, take some notes, go back, rewind, look at it again, that's fine. Now everything else is easy. Watch this. Step 2 is just to find n minus 1. Well, what's n? Here's the top number now. So now we're looking at the bottom number. N minus 1. What's n? N is the sample size. We have 1, 2, 3, 4, 5 grades. So we have 5 minus 1, which is 4. So now we have our top number, 1920, and our bottom number, which is 4. So step 3 is to find that square root, which means the standard deviation will be the square root of 1920 divided by 4. You can do that in your calculators. 1920 divided by 4, let's see what that is. 480. And then we got to take the square root of that. And then the square root of 480 is, let's see, square root of 480. Ah, shucks, my calculator. All right, let's try that again. 480 square root 480 equals 21.9. That is the standard deviation. Now, I'm going to explain this. We got our top number, our bottom number, and here is our answer. This is our answer. I'm going to explain how we interpret this, but this is how you calculate it by hand. Now, this number on the inside is also a very special number. We'll call that S squared. That's called the variance. This is called the variance. So remember, you calculated the variance when you attempted to calculate the standard deviation, because the standard deviation is the square root of the variance. So this number on the inside, you calculated the variance as you were attempting to find the standard deviation. So if I wanted to just take 21.9 and multiply it times 21.9, that's going to give me 480. It's the square of the standard deviation. So this is the standard deviation. And then S squared, the standard deviation squared, is the variance. All right, very good. Now, so let's think about how we did this again. First, you had to make a table for the top number. Then for the bottom number, you took the sample size, which in this case was 5, because I had 5 grades, subtracted 1 from that, and then you did your substitution and you simplified and took the square root. Now, I know all of you don't want to do that. So let me stop sharing this screen, and I am now going to share with you what I have Googled. I want you to Google a mean and standard deviation calculator. Now I've got to find mine again. Give me 1 second because I had it up. Mean and standard deviation calculator. Okay, that's all I Googled. Mean and standard deviation calculator. And what came up was calculator.net. Now let me show you what came up. All right, calculator.net. Share screen. I love Zoom for this reason. All right, so let's put some numbers in here, separate them by commas. Here's Charles's grades: 87, 78, 70. This is calculator.net, standard deviation calculator. 58, 42. Again, I'm going to show you how to use SPS, but I just want to get you the concept. SPS is wonderful. We'll do all of this stuff in 1 second. However, you got to know something a little bit about how to interpret these numbers. And that's what I'm trying to teach you. Now, it's asking us, do you want the standard deviation of the population or do you want the sample? What's the answer? We want the sample. So I click sample and then I say calculate. It gives me all of those funny looking symbols, but it tells me that the standard deviation is for Charles 17.57, which means I think I wrote the numbers down wrong because that doesn't look right. So let me go and do it again. Oh, I wrote 87, but I should have written 82. All right, now let's try it again. That's right, 16.2. So Charles' standard deviation was 16.2. So Charles' mean score was 66, and Charles had a standard deviation of 16.2. And you also see the variance S squared as 264. Now let's put this all together. I'm going back now to, I'm gonna stop sharing this and I'm going back to the document camera so we can put this all together and make sense of it. So here's what we know about Charles. Charles, okay, here's what we know. Okay, so I'm gonna call this Roman numeral 4, I think it is. Big picture. Here's what we know. All right, so Charles, mean 66, standard deviation 16.2, variance 264, range, don't forget about the range, was 40. Then Bryce, mean 66, that's his average grades, which means that's a D, right? But we're not gonna give him a D. We calculate the standard deviation was 21.9. The variance was 480, and the range was again 40. All right, let's just focus on these two because we already know that Ann gets the D. We're trying to figure out what grades that Charles and Bryce should get. So what does this say in class? When we look at the standard deviation for Bryce, it is larger than the standard deviation for Charles, which means Bryce's grades has more variability, has more spread from the mean. It is more different from the 66 than Charles's grades. And even if you look at the variance, this number is considerably larger than 264. So that means Charles and Bryce should not get the same grade. So how will we determine what grade they should get? Well, I'm going to use the median, the middle number. If I look at Charles' median is a 70, which is a C. If I look at Bryce's grades, Bryce's median is an 82, the middle number. Look at the distribution of grades. I'll show it to you again. The middle number, 82 and 70. That's the median. It splits the data set, the number that falls directly in the middle, which means Bryce should get a B and Charles should get a C, and Ann, we already established, should get a D. So how do we do this? At minimum, you need to look at some measure of center. We typically in education like to use the mean, and some measure of spread. Standard deviation is probably one of the better choices. Okay, wait a minute. I don't think y'all saw any of that. Let me see if I can do that again. Are you kidding me? I wrote all of that out and y'all didn't see it. All right, let's try it again. I know you heard me, but let's make sure you can see what I'm saying. All right. Here's what I attempted to write and discuss. So now let's look at this again. Charles's grades, let me use my little pointer here. Charles, on average, had a 66. Standard deviation, 16.2. Variance, 264, range 40. Bryce, average grade was a 66, but we know we're not going to give Bryce a D. Standard deviation, 21.9. Variance, 480, range 40. Since the ranges were the same, we decided to focus on the standard deviation or the variance to help us make our decision. You can see that this variance is larger than this variance, which means there's more variation, more difference from the mean. More difference from the mean, which means if it's further from the 66, then it's probably Bryce should have a higher grade than Charles. That's what that means, because 21.9 is larger than 16.2. That means Bryce's grades are better than Charles's grade in the sense that they're further away from that D. And so to decide what grade they should get, we should look at another measure of center. We'll say, in this case, the median, because we learned last class that the median is a resistance statistic. And so when you think about this, the median, the middle value for Bryce was 82, and for Charles, it was a 70. Those were the middle values. That's the median. And so let's say that a 70 is a C and an 82 is a B. The point is they should not all receive the same grade. Again, are teachers going to do all of this? No. But you as researchers should know that when you're reporting and you're describing data, you should at least use a measure of center, like the mean, and a measure of spread, like the standard deviation, so people can see how your numbers differ from that mean on average. Remember, the standard deviation is the difference, the average difference from the mean. So I hope that you learned something about standard deviation, and I hope that that article now makes sense. So hopefully you can go back and read the article and make more sense of it. The next video will be about measures of position.